Hello, today I'm going to talk about Chebyshevs theorem and the empirical rule. Excuse me, I'm recovering from a cold, so my voice is a little tired. Okay, consider a population of 1,024 mutual funds that primarily invest in large companies. You have determined that mu, the mean 1 year total percentage return achieved by all funds, is 8.2, and that sigma, the standard deviation, is 2.75. According to the empirical rule, what percentage of those funds are expected to be within one standard deviation of the mean? And according to the empirical rule, what percentage of those funds are expected to be within two standard deviations of the mean? Well, the empirical rule says for any normal distribution, about 68% of the results will fall between one standard deviation from the mean, and about 95% will fall within two standard deviations, and 99% will fall between three standard deviations. So if we go back to the problem, for this it will be 68% of these funds will be within one standard deviation of the mean, and 95% of these funds will be within two standard deviations of the mean. Okay, so those two questions are pretty simple because all you have to do is look at the empirical rule. According to the Chebyshevs rule, what percentage of these funds are expected to be within one, two, or three standard deviations of the mean? Well, let's talk about Chebyshevs theorem. This is extended. This allows you to extend the idea to any distribution, even if that distribution is normal. The theorem states that for a population or sample, the proportion of observations is no less than 1 minus and then 1 over k squared. You can use Chebyshevs theorem to get results for standard deviations over 1. So if we go back and calculate, k is the number of standard deviations. So we're going to figure out the percentage. So let's say k is 1 standard deviation, plus or minus, doesn't matter. We're going to plug it back into Chebyshevs. It's going to be 1 minus 1 over 1 squared. 1 squared is just 1. So you have 1 minus 1 over 1. 1 over 1 is just 1. So you end up with 0. So for one standard deviation, you cannot calculate. So we cannot come up with a percent for one standard deviation. Let's say k is 2. I'm going to plug 2 back in. 2 squared is just 4. 1 over 4 is 0.25. When you subtract 0.25 from 1, you get 0.75. So for two standard deviations, we expect at least 75% to fall within two standard deviations. You just move it 2 places over to the right to make it a percentage. Now let's say we have k is equal to 3. We want to know for 3 standard deviations. 3 squared is just 9. 1 over 9 is 0.11111. It keeps going. When you subtract it from 1, you get 0.8888. It keeps going. You can round it up to 0.8889. So for Chebyshevs, with 3 standard deviations, we expect 88.89% of your data to fall within those bounds. This is a percent. Okay? So that should help you with the k is equal to 2, k is equal to 3. Now, according to the Chebyshevs rule, at least 93.75 of these funds are expected to have 1 year total returns between what two amounts? Well, what I'm going to do is I'm going to set this equal to 0.9375. I'm going to change that percent to a decimal. And I'm going to solve for k, because k will tell me how many standard deviations. Once I figure out the standard deviations, then I can figure out what the two values are. So let's go ahead and solve for k. The first thing I'm going to do is I'm going to subtract 1 from both sides. I end up with negative 1 over k squared is equal to negative 0.0625. Okay, let me go to the next screen, see if I have more space. I don't. Let me clear this. I'll rewrite it so I have more space. 0.0625. Well, both of these are negative, so we can just change to positives. It won't, we're going to eliminate the negative sign. What you can do now, you can put this over 1 if it's easier for you, and then we can cross multiply. So then I have 0.0625 k squared is equal to 1. To get k squared by itself, I'm going to divide both sides by 0.0625. When I divide out the right side, I get 16. To get k by itself, I need to take the square root of both sides. So k is equal to 4. So we know that with 93.75%, we're going out 4 standard deviations. Well, if you recall, if we go back to the problem, let me see if I can go back. Oops. The problem told us that the mean is 8.20 and that the standard deviation is 2.75. So what we can do, since we know that 93.75 is 4 standard deviations out, all we have to do is plug in the mean. We're going out 4 standard deviations, and the standard deviation is 2.75. So when I multiply 4 times 2.75, I get 11. So now you'll have 8.2 minus 11, and then 8.2 plus 11. That's what that plus or minus means in the middle. You have to add and you have to subtract. So when I subtract, I get negative 2.8. And when I add 11, I get 19.2. Okay, so oops. It says, so what two amounts? The answer would be negative 2.8 and 19.2. Okay. All right. Hope this helps.